Okay, so in this video we're looking at reading or interpreting histograms. Okay, and these questions can get, I would say, a bit trickier. But if we know a pretty key piece of information, which is that area represents frequency, then we're kind of good to go. Just quickly, right? Thank you. I've taken these two graphs from Corbett Maths, so thank you, Corbett Maths. Anyway, let's begin. So right, the key bit of information, right? Remember, area of a bar represents frequency in a histogram. That is really, really important. This statement here is really useful. Okay. Before I even get into the question, note, right, I've got frequency density, which is here, but I've been given no values for that there, which is not particularly useful as it stands. So I'm probably going to need that at some stage. Well, I will do. And I've been given the speeds here of whatever I'm looking at. Anyway, the question says, right, the histogram shows the speed, miles per hour, of some cars. And we're told that 24 cars travelled faster than 40 miles an hour. And that's really important, okay? Because, right, a bit of an issue I've got is, well, and part A is saying how many cars travelled slower than 20 miles per hour. So I want to see how many cars are below 20. So basically, I want to find the area of this bar here, because area of a bar for a histogram is frequency. But I need this value here to do that. Okay, but I can get there eventually by knowing that 24 cars travelled faster than 40 miles per hour. So I know, right, that the frequency above 40, I'm looking at this bar, this bar here is above 40, and I know that the frequency there of cars is 24, which is really, really useful. Okay, because I now know if I go and draw this bar out over here, so let's go and just quickly draw out a rough sketch of it. So we've got this bar like this. Okay, well, the width of that bar is going from 40 to 50, so it's got a width of 10. I know that the frequency of it, there are 24 cars in that bar. Right, remember 24 is, oh, that's not what I want, let's make it yellow. 24 is frequency, so I can go and say that in here, I've got 24 cars. Well, area of a rectangle, 10 times what is going to give me that 24? Well, the height of it must be 2.4, because 2.4 times 10 is 24, which then means if I sort of read across, right, from this point here, right, this value there, that must be equal to 2.4, okay, which is really useful to know. Right, let's get rid of that line now, a big one, I don't want that. So we're just saying that this value here must be 2.4, this increment here, okay? Well, it's going up, there's sort of 1, 2, 3 parts to that. I can break it up. I can go and say, well, 2.4 divided by 3 is 0.8. Okay, so that must mean that I'm going up in increments of 0.8 and then 1.6, like 8, 16, 24, 32, 3.2. We'll keep going because this might be useful for later. 4 and then 4.8 and then 5.6. So now I've got my frequency density scale, which is really useful because part A is saying how many cars travelled slower than 20 miles per hour. So I'm basically looking right at this bar here, because everything in here, right, is less than 20 miles per hour. Okay, so for part A, well, how do I find the area of this bar? If we go and draw a quick sketch of it, right, okay, it's like looking like this, isn't it? Right, just a really rough sketch. And we know that the width of that bar is from 0 to 20, so 20 across, and the height of it is 0.8. So how do I find the area of that rectangle? Well, remember, area of the bar is frequency. The number of it is just going to be 0.8. So 0.8 times by 20, which is equal to 16 people. Also, 16 cars. How many cars travel slower? 16 is your answer for part A. Okay, and there we go. Right, what is part B saying? Part B is saying, estimate how many cars travelled between 15 miles per hour and 35 miles per hour. Let's go and draw those on our diagram. So where's 15 is going to be? 15 is going to be here. Okay, and let's make that a straight line, a bit neater. 15 is there. And also 35 is going to be from up to here. So we're sort of looking, right, let's use a different colour actually for both of those. Let's go and use green. So 15 is going to be here, and then 35 is all the way up here. So basically, right, I now want the area of everything between 15 and 35, and let's go and highlight that now in green. It's going to overlap here, apologies for that, but that would be okay. So I want this bit, I then want this bit here, and I also want this bit here. Okay, so I've got to go and get the areas of each of those bars. Okay, bit messy, but hopefully that is okay, and you can read that well enough. Okay, let's go and call these bars. Let's use a different color. Let's go and call these bars, right, bar 1, bar 2, and bar 3, and let's go and work out the areas of each of those bars respectively. Okay, so for bar 1, okay, for bar 1, the smaller one, well, it's got, and if we go and draw it out, so I'll make it really clear, hopefully, okay, to you guys, okay, because remember, area is telling you how many people there are, or how many cars there are in this case. It's got a width of 5, and it's got a height of 0.8, so 0.8, and we'll work out the area in a second. Bar 2, okay, bar 2 has got it's a bit bigger, isn't it? It's got a width of 10, and it's got a height a bit taller, something that looks like that. Okay, you don't need to go and draw all these bars out in the exam. I'm just kind of showing you exactly what is going on. We've got a width there of 10, and we've got a height of 4, so that can go in there. And then bar 3, okay, it's a bit of a longer one, so there we go, up, there we go, down and across. So this one, right, has got a width of 5, so 5 across, and a height of 5.6, okay. And now let's go and work out the areas of each of these, because remember, area of those bars is frequency. So the first one's going to be 0.8 multiplied by 5, okay, which is going to be 4. So 0.8 times 5 is equal to 4. So there's 4 cars in that first bar. We've then got this one, 4 times 10 is the area of that rectangle, which is going to be 40. And your last one, you've got 5.6 multiplied by 5, which is equal to 28. Okay, so you've got 4 cars in the first one, 40 and then 28. So to find how many cars in total, right, we've got to go and add them together. So we're doing 4 add 40 add 28, and let's go and do that. 4 add 40 add 28 is equal to 72. Okay, so 72 cars between 15 and 35 miles per hour. Let's go and use yellow for that. Okay, look, you don't need to go and draw out all the bars in the exam at all. I'm just trying to make it really clear what is going on. So hopefully that was clear. Okay, so that's question 1, A 16, B 72. Example 2. Again, I noticed straight away, right, there is no values here for my frequency density, which may be a problem, and it will be a problem, probably. And the question says, our histogram below shows the ages of rugby players. Okay, there are 668 players, right, that's pretty key, I'm guessing. That many players that are under 26 years old. Work out an estimate for how many players are over 32. Right, so we are told, importantly, that under 26 years old, so we're looking at this part here. Okay, let's actually use a different colour, otherwise it gets confusing. 26 is here. We're told we've got 768 players that are below that age. But unlike last time, right, I can't easily get a scale here because it doesn't tell me how many players are in one of the bars, which is different to this one. So this time, right, I need to use a bit of a different approach. I know there are this many players under 26, so let's go and highlight this. So everything here, okay, and everything within this part of my histogram. Okay, it's quite hard to shade on my little device. There we go. Okay, so I know that everything within these bars here is worth 768. So if I can find the value of one of those little squares here, okay, I can see how much one square is worth because I can share it between 768. Right, so let's begin. Right, let's see how many squares I've got in total. Right, so I know that in like one clump of squares, right, it's going 5 across and 5 down. So in one block, let's keep it in red. Right, in one block of squares, okay, it's got 1, 2, 3. It's going 5 across and also 5, 1, 2, 3, 4, 5 down. So there must be a total of 25 squares. So one block of those is equal to 25. Well, how many of the exactly full ones have I got there? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right, I've got 18 full ones. I've got 18 of those. And I've also got these ones up here, which I've only got, they're sort of 2 up and 5 across. So if we can just go and quickly draw that in. So 2 up and 5 across. It's something like that. 1, 2, 3, 4. Okay, so in one of those, right, there are 10. And I've got 3 lots of them, we can see here. 1, 2, 3. So I can times that there by 3. 10 times 3 is equal to 30. And sorry, the first one, 25 times 18 is equal to whatever it's equal to. That is equal to 450. Right, so in total, I can work out how many squares I've got in total by adding those together, which is going to be equal to 480. Okay, so I've got 768 players being shared between 480 squares. So to find out how many players I've got per square, right, let's go and do 768 players, okay, divided by 480 little squares. So I can find out the value of one square, okay, because then I've got players per square. So if I go and do that now, 768 divided by 480 is 1.6. So I've got 1.6 players per square, okay, which is now useful. So I literally know in one tiny little square, so like one of those squares there, that is worth 1.6 players, okay, which is now useful because I want to go and find how many players are over 32. So if I go and draw in a new line in blue, I'm now looking at people that are over this age, which is here. Oh, I wanted that to be in blue. So over this one here. Okay, and I highlight that in, let's go and use blue, keep it consistent. So I'm looking at everything over 32. So all of these squares here, and then all of these squares here, and then all of these squares down here. And be really careful. I remember in class, I think I miscounted these squares, which is easy to do. So I'm now going to work out how many squares I've got here. So again, how many full ones have I got? I've got a full block there. That's 1, 2, 3. Is that a full block up there? I don't. So that's 5, 10, 15. Right, this one here is not a full block. It goes up by 4, not 5. So I've got 1, 2, 3 full ones there. 4, 5, 6, and then 7 with some extra ones left over there. Right, so I've got 7. I've got, because there's 25 little squares in each of those ones, and I've got 7 full ones of those. Okay, so 25 times by 7 is going to be 175. Okay, which is good. But then I've also, right, let's go draw out the diagram there to make it really clear to you. So I've got 1, 2, 3, 4, 2, 3, 4. Okay, so I've got 25 of those lots. But also, I've got these sort of extra little fiddly bits at the end. I've got that there is 5 across and 4 up, which I've got to take into account. I've also got this one here. So that one there is going to be, if I go and draw it out, so I've also got, it's going up by 1, 2, up by 4. And it's got still 5, 1, 2, 3, 4. So this one is going to have 5 times 4. It's 5 wide and 4 up, which is equal to 20 squares. And I've also got this bit down here, right, which is 1 up and 5 across. So I've also got 1 up and 5 across. So 1, 2, 3, 4, 5. So that's just going to be equal to 1 times 5, which is equal to 5 squares. Okay, so in total, right, and I'm pretty sure I haven't missed anything out there. I don't think I have. If I have, you can always let me know. But I think that's right. Right, so I'm now going to say that in total, in this blue part here, I've got 175, add 20, add 5 squares, which is equal to 200 squares. Okay? And there's 1.6 players per each little square, I've got 200 squares here. So to find out how many people are above 32, I can go and do 200 and then multiply that through by the 1.6. And that's going to give me my final answer, which is equal to 320 people. Okay, so that is my final answer. Okay, and let's keep that in yellow for our final answer. There we go. Okay, so 2 really good questions there on histograms because they're sort of using different approaches. Problem solving ones, I would really say. Okay, hopefully that was useful. They're a bit fiddly with these. You've just got to be really careful with it. I know in class I miscounted the squares and it became a bit of a nightmare. I think that's what happened, but hopefully that was useful. And I believe that is the end of the grade 7 playlist. Okay, thank you.